Swayam Prabha. Digital India. Educated India.
So today we continue the discussion on planning of landfills. Last time we had started this topic and we had seen what are the options when you place waste on ground, what are the options you have in terms of the plan and the layout of the landfill, and what are the options that you have as far as the section of the landfill is concerned. So, 2-3 important things we did last time. What's the design life of a landfill? Active period when the waste will be filled, plus post closure monitoring period. We would like the active period to be as large as possible. Typically it should be between 10 to 25 years. It should not be less than 10 years typically, based on the amount of waste being produced by a city or a group of cities. That landfill site area can be decided. And I use the word group of cities because now the concept of regional landfills is also coming up in India. Why regional landfills? So take a look at Delhi. Delhi is surrounded by different states and the city has expanded to its boundaries. If you want to go more south, you have Haryana. If you want to go more east, you have Uttar Pradesh. If you want to go west, you have Rajasthan. So all these kinds of, we are like an island. So if 2 or 3 states or 2 or 3 districts or 2 or 3 municipalities in a district are having difficulty in finding land to dispose, then they can try and set up a regional facility. That means within 50 kilometers, if you have a spot where you can set up a facility, you draw a circle with a 50-kilometer radius, and all the cities which are touched by that, they can actually send their waste to this regional facilities. So depending on the waste coming in, you have an idea of the area that you need for the design life. To be able to get an area of the design life, you'll have to fix the height. So that brings us to the section, the sectional view of the landfill. And we talked about below ground landfills, above ground landfills, and side slope landfills and valley landfills. So just think about what can be the typical height of such landfills, and we will address this because you have a particular quantity of waste which will come in 20 years. If you know what is the limit of your height, you can say how much area that you need. So let's continue from where we left off last time. Okay, we talked about an above ground landfill last time. It could look like this or it could look like this. The difference between the two is this has got embankments. So if you are having sludge coming in from which little bit of fluid might, though it is dewatered sludge, some fluid might come out, you might want to have these embankments. The other is that these embankments are made of compacted soil, so these can have steeper slopes than this. So these are 2 options and it will look like this in plan or in a 3D view. Now let me go inside this landfill and what do I find? I find small cells, solid waste cells. Now let me go closer. At the base of the landfill I have a liner. It's a multiple layered system, and at the top I have a final cover. Base, liner, final cover on the slope and final cover on the top. These are daily cells. Every day the waste will be placed in a cell. So day before yesterday it was placed here, yesterday it was placed here, today it's placed here. and then you see thin layers here. So, the concept of an engineered landfill is that there is a daily cover. At the end of the day, you do not leave your waste exposed. This may be soil cover. We tend to use C&D waste cover here as long as it is not very coarse, because the idea is to have no pests and rodents which are accessing this. So, if you put soil cover, they will not be able to access it so easily. And then something called an intermediate cover. So, final cover, intermediate cover and daily cover. An intermediate cover comes at the end of a phase, and I will talk about that a little later. But inside the landfill it looks like this. You have a lift or a height. That means you have fixed the height of the daily covers. Your landfill may be 20 meters high or 10 meters high, but your daily cover may be only your daily cell height may be 1.5 meters. So, that is the lift. That means the daily cells increase the height by 1 to 1.5 meters every day. And a phase is typically the total height achieved after 1 year. This we will look at a little later. So, which are the components as geotechnical engineers that we are going to be dealing with? We are going to be dealing with liner system, the leachate collection system, daily cells, daily covers, lifts, yearly phase. The landfill must be closed every year. So, your phase which is done every year, which must be closed with an intermediate cover or preferably with a final cover. The concept of intermediate cover, the concept of a bench. You may have a berm or a bench or a terrace as they call it, final cover, and then the gas collection system. So, this is what we will be dealing with in our designs. First, let us look at the issue of landfill capacity. How are we going to estimate the area that we need? Or if we have a fixed area, how are we going to estimate the height to which we have to take the landfill? So, we have to estimate the quantity of waste, we have to estimate the compacted density. If I know the quantity of waste in terms of how many tons of waste is coming per day, and if I know its density, then I can know the volume. Over and above the volume of the waste will be the volume occupied by the liner and the cover, because every day they are coming into position, and some volume will reduce due to settlement. That means as biodegradation goes on, you will have more airspace created. So, the density of municipal solid waste, and please remember that I am talking of the green waste and the food waste, is between 0.6 to 1.2 tons per cubic meter. In soil mechanics terms, this is the total unit weight. Okay, this is the total unit weight. If you have inorganic waste, most of the waste coming out from industries is inorganic, right? Then it is more having densities like soil. What is the unit weight of soil? Typically compacted soil will have 1.2 to 1.6 unit weight. So, in hazardous waste landfills, this, if you are having inorganic waste, then this may be the density, but for municipal solid waste, this may be the density. If you have inorganic compacted waste, waste is not going to settle much, you are not going to get more airspace, especially if you have compacted it properly, it might settle by a few percent. So, do not rely on this additional capacity. The municipal solid waste does give you settlement, but does not give you in the first few years like that. I mean, the biodegradation process actually slows down because you have put a cover. So, when we talk that we can get 20% or 15% settlement in municipal solid waste, we are talking of it's happening over 20, 30, 35, 40 years. So, you have to be very cautious if you are going to take that volume in your area computations. So, in a very simple sense, I am going to do this very simply. Waste generation rate is W tons per year. If you know the population of a city, then you can estimate the waste either from the records available with them many a times they may not have a record, then you have to presume what is the per capita waste which comes out. So typically in India, in a city like Delhi or in the mega cities, you may have 0.35 kg per person. In rural areas and villages, it may be much smaller. In America, it may be much larger. How high? Anybody has an idea? So it could be, in a developed world, it could be why? Because the more developed you are, the more consumptive you are. So more consumptive, simple indication is the amount of electricity we consume, the amount of petrol we consume. Developed world consumes more petrol than we do per person. They use more electricity than we do per person, and they produce more waste than we do per person. And really, the rural or in the village setting, we produce much lower waste than the city. So if you know the population, and if you have this, this is a rough figure, this is developed countries, it can have a wide variation. Then you know that you are producing W tons per year, and let's say the active life is N years, then the total waste is W into N tons. Now, it's a simple formula. We have not taken into account the rate of growth of population. But this is not very important to the developed world because the rate of growth of population is not very high. In some countries, it is negative. You are aware of that? The trees are taking over. What does negative growth rate mean? That this year I have 1,000 people, next year I have 950 people. So there is a negative growth rate. And in those developed countries, houses are being taken over by the trees. So you have only two options, either to promote marriages and more children per marriage, which may not happen because you are developed and everybody is independent and working. And so at best, marriage they may have one child per couple. The other option is to open your borders to immigrants. So if you are a negative growth rate society and there is a positive growth rate society like India. So if you have a population growth rate, then this has to be multiplied by that appropriate figure. I mean, it's like just simple interest or compound interest. You have a population growth figure, so it will be 1 plus something to the power of n. And then you will get the total waste in your design period of n years. You divide this total waste by the density and you will get the volume. So how much does daily cover occupy of that volume? Daily cover, I mean, I told you about a lift of 1.5 meters. And what is the thinnest layer of soil you can spread? If I ask you to use a dozer to spread soil, what is the thinnest layer you can spread on ground? By mechanized equipment, what is the thinnest layer of soil you can spread? Or by a human being, what's the thinnest layer of soil you can spread? 1 millimeter? 10 millimeters? Well, a dozer or a grader or a mechanized equipment can spread 6 inches to 8 inches of soil. You can't ask him to spread 10 millimeters of soil. So if you are doing mechanized daily cover, you are going to have a 6-inch soil layer. Whereas somewhere in the municipal solid waste management rules or the manual brought out by in India, they have said 15 millimeters of soil. I think they are off. How many millimeters is 6 inches? How many millimeters is 6 inches? 150. Thank you for that correct statement, because 1 inch is 25 millimeters approximately. So 150 mm is the soil thickness. So if you have a 1.5 meter thick and you have 15 centimeters, you are taking off that much of the volume. So what is shown here is volume of the daily cover is 0.1, and the final cover and the liner are more than a meter, more than 1.5 meters, sometimes 2 meters thick. So there's a volume taken by them as well. So if you have a volume of waste, the entire volume is not going to have that waste in it. So the total volume will be V plus 0.1 V for daily cover plus 0.25 V. Suppose the area available is A, right? Then the area required for the infrastructure, as I said, 20%. If all the area is going to be used for placing the waste. So you can get the height of the landfill very simply as this becomes 1.35 V divided by 0.8 A, and it will give you the height plus the depth of the landfill. That means to accommodate the waste for the next n years, if I am being given an area A, then I need to have a height plus depth of 1.3 V by 0.8 A. Now, is that height more than acceptable or less than acceptable is the next question. But the problem could be the other way around also. If the municipality fixes the limit, what's the problem with having a very high height? Some stability issues of the waste, slope stability, but there's a larger issue of visual aesthetics. I mean, suppose you are a city and most of your houses are single storied or two storied or 4 storied. Then if everything, if the skyline is 4 storied, then if the skyline is 4 storied, then the mound should not rise above the skyline. So it's aesthetics issue. If you have high-rise buildings, no problems, you can have a higher waste dump. It should not be the dominant feature of the landscape. So you can fix the height and then you know how much area you need. So if you're designing a landfill for the next 20 years, you know the amount of waste that's going to come out. You fix the height as 20. Municipality says you can't go beyond 15 meters. Okay, we will not go. Give us this much area. You should be able to find A. So the area that we need is desirable for the full life. If I can get area for 25 years, very nice. Nothing like it. If I can't, whatever is available. The shape and plan will be as available. It will neither be a square, nor be a circle, nor be a rectangle. It will be as available. How deep can you go? When we are trying to actually now say that the municipality says don't go beyond 15 meters. Well, then can I go below? Sure. How deep can I go? Well, somewhere there will be a water table, somewhere there will be a bedrock. If neither of the two are available, how deep will you go? Well, we never typically go deeper than the unsupported excavation we can do in that area. So usually we go 7 to 8 meters for unsupported excavation. Technically we can go to very deep areas as well. So really, if there's a 15 meter cap on the top and there's a 7 to 8 meters cap at the bottom, you are going to have an H plus D of about 20 to 25 meters. So typically, as I said, for aesthetic reasons, 15 meters is acceptable. However, landfills can be more than 40 meters high, especially in valleys. I mean, if you have if you are in a mountainous region, then you can have a landfill which is 40 meters high. It's like a dam, a little dam keeping reservoir water behind it. Here, instead, you're going to fill it with waste. Any questions on this? Any issues? As I said, this formula is approximate. You have to set it right by the rate at which the population is going up. That's important, especially when you are doing 25 years cycle of life for designing the landfill. The next most important aspect is phased operation. In the end of last time's lecture, somebody asked me, when do you actually put the cover on the landfill? And I said, this is the most critical question, because many people do not understand this, that you don't cap the landfill in the end. You don't cover the landfill at the end. You cover it before every monsoon. So in a country like India, we want to cover a landfill before the main rains come in. So it means every year we have to cover the landfill. To be able to cover the landfill, are we talking of an intermediate cover or are we talking of a final cover? Please understand that the intermediate cover is slightly thicker than a daily cover. It's not an impervious cover. A daily cover gets covered by another cover within a few days, another cell within a few days. So suppose I have a below ground landfill. And this landfill in this direction is going to be filled in 5 years, let us say, or 4 years, whatever. Then first I have got the form that I am only making a landfill which is below the ground. Why? Because my municipality says I want to make a football field over it. I don't want you to elevate it. It creates problems. So I am going to use it later. So you have this volume, you have the height or the depth, so you can see how much waste you can put in it. The next thing is to decide the phases. And a phase is basically a sub area of the landfill, and it will be a yearly phase. So I want to say 5 years, let me try. First year the waste will come like this, or maybe I'll do 2 options. That's one way of doing it, first year, second year, third year, fourth year, and the other way of doing it is so many examples exist where people have not understood this concept. But really, which one is better in terms of phases? You can do 1, 2, 3, 4, 5. Which concept is better for phasing? Any thoughts? Why?
Because in the first case we have to go for a movement of the whole area.
So, here, the movement like this, for example, may be the same as movement like this.
That liner cover system is daily cover system.
Right. So, what about the daily cover system?
Larger area is exposed to the environment for a long time.
Basically, larger horizontal areas exposed to rain. And when it rains, I can't put a final cover here. Can I put a final cover here? Because if you are going to put a final cover after every phase, it's going to be very expensive. Whereas I can put a final cover here because I've reached the top. Do you understand what I'm saying? So this allows me to reach the top at the end of the year, and before the monsoon comes, I can put a cover. So this becomes my final cover. And I have my daily cells here with their daily covers, okay? Is this the final cover, the slope? It will be more than the daily cover because it's going to remain exposed for 1 year till this cell fills up. So it is intermediate cover. So this is final, this is intermediate because it's not going to be the final cover. So this is daily. So this is better than this. Why? At the end of first year, when the monsoons come, there is no waste here. There is no leachate. The rainfall which can make leachate is this rain multiplied by this area, whereas here it is the same rain multiplied by the full area. So obviously this will create much more leachate. So this is not acceptable, this is acceptable. That is the concept of phases. So the term phase describes a sub-area of the landfill. It comprises of daily cells and is covered with daily cover. The daily cover is usually 15 centimeters thick. Each phase is designed for a period of 12 months. It is filled from the base level above the liner to the final cover level and then capped with the final cover, leaving a temporary sloping face with intermediate soil cover. Now instead of being 6 inches thick, the intermediate soil cover may be 4 layers of 15 centimeters, that may be 60 centimeters, that is about 2 feet, or you are too conservative, you want to make it 1 feet, but it will be much thicker than the daily cover. It has to be ensured that each phase reaches the cover and that the final cover is in position before the onset of monsoons. So if the monsoons come in Delhi in July, August, and the end of the summer in June, I should have put the final cover at the top. I should have reached the top and I should have put the final cover at the top. That is how you will decide the size of the base of the phase. And this is not understood by many. So between this and this and this, this is better. And you can phase it like this. I am just showing you another example in plan, a small landfill with 4 phases, 1, 2, 3, 4. So if you look at it, at the end of the first year, this phase has been completed. Can you see? This is a plan view and this shows the slope. So it's rising above the ground. So in the first year you fill this and then you cover it. While you are filling this, you are putting the liner for the next in preparation, right? And this is an so let me say 1 year is over, the second year is on. So in the first year you will place the waste here, agreed? At the end of the first year you will cover this. In second year what will happen? While you are placing the waste here, you are putting your liner here. So in the second year, this is under operation. This has been filled, it is covered. This is under operation, means waste is being put on it on a daily basis. And this is under preparation, you are putting the new liner for the next year. And then after 3 years are over, all this is covered with final cover. This is an operation. So in this, all the rain which falls here is not leachate. The rain which falls here is not leachate. The rain which falls here is not leachate because it runs off the cover. Only the rain which falls in the operating area becomes leachate. So it's a much smaller amount of leachate that is generated. And that is the most critical option, issue. So you understood? Incrementally fill the waste in small areas. And what do you do during the monsoons? During the monsoons you can do 2 things. Landfill may be kept capped. You may cap the landfill. Final cover is on the top. On the side slopes you can put a geomembrane or tarpaulin, something which does not allow water to go in, on the intermediate cover. And it may be kept non-operational for 2 months. Or what they are doing in Ankleshwar is, the waste comes in from the industry, they have capped it, they have got the temporary geomembrane also. The waste is put in the temporary holding area. It is a double handling now. The moment they have a window, that today it is not raining for the next 4 hours, they will remove the tarpaulin, and put the waste there and cover it again, because otherwise you have to create a temporary holding area for 2 months. That's pretty expensive because you have a large area is required to be covered. So they are opening it in the windows where they can place it. So landfill may be capped and non-operational. All waste may be stockpiled in a temporary holding area covered with roof, or you may occasionally remove the material from the roofed temporary holding area to the landfill when there is a weather window. Sometimes you may make special monsoon phases in separate area of the landfill to place the waste. So what happens is, during the monsoon the waste is smaller, but the rain is more intense. So your leachate collection systems have to be larger capacities. So you may make a monsoon phase, that all right, during the monsoon I will not place it in the main landfill, I will send it to my monsoon phase, I will place it there, I will try and put it only in the weather window when it is permitted, but still you make that for handling larger leachate. So such phases would have temporary mobile covers and a leachate collection system with high capacity. So monsoons have to be treated either this way or that way. How do you manage emissions? Now you've made the landfill, you are collecting leachate. What do you do with the leachate? Can you discharge the leachate to the drain? First question. Can you discharge leachate to drain? It depends on the type of landfill you have. You have a construction and demolition waste landfill, leachate is coming out beneath it. Can you discharge it? I don't know. I have to test it. If the leachate meets the standards for discharge to drains specified by the Central Pollution Control Board, then you can discharge it. Then you can discharge it. So if it doesn't, then you have to treat it. So definitely hazardous waste leachate and municipal solid waste leachate cannot be discharged. It has to be treated. So how do we treat it? One of the options is to, if you have a net more evaporation than precipitation, then you can make solar ponds. You know, you have the evaporation and precipitation figures for your area. If you find that at the end of the year all of this will evaporate, then you can put it in a solar pond. This is what people do. But solar evaporation ponds give you a lot of smell. So there is an odor issue at your site. It's not the best way to do this. Still, if you don't have any facility, you haven't set up an effluent treatment plant, it's expensive, you don't even know the kind of effluents which are going to, contaminants which are going to come out. You can't design an effluent treatment plant till you know the kind of contaminants which are going to come out, especially in industrial hazardous waste. Then you will say, all right, I will collect the leachate for 1 year and then see what kind of ETP I have to design. So you can first put it in solar evaporation ponds, or you can put it in forced evaporation multiple effect evaporators or incinerators, where this leachate is in the form of a jet and a slurry. It is placed inside the boiler, and these are design systems that it will evaporate and the powder will fall down. So inside the incinerator or inside a multiple effect evaporator, you are designed that the leachate will evaporate and the powder will be collected, which will go back to the landfill. In a solar pond, there is a lot of odor. The other two are closed container systems. You may have an off-site treatment plant. At Ankleshwar, what is happening? The sludge from the effluent treatment plant is coming to the landfill. When the rain falls on the landfill, the leachate comes out. The leachate has the same contaminants as the effluent treatment plant which it is treating. You send the leachate back to the effluent treatment plant. So the better you handle it, the less is the leachate, but you can send it to an off-site treatment plant. That means not on your site, you don't want to invest in it, there is an ETP of the industrial area anyways, the contaminants are similar, it goes back, again the sludge comes, again it comes back to you. Or you can make an on-site treatment plant. You can have an on-site treatment plant. And finally, you can have recirculation. Recirculation is not the end of all problems. You don't know what to do with the leachate, put it back in the landfill. After some time, concentrations will become so high. Some concentrations may change because the leachate may react, but in the end, you have to do a blowdown. A blowdown is leachate has become so concentrated, it has to get out of the system. So don't think that leachate recirculation will reduce the contaminants, or it can be infinitely adopted. For a small period of time, say for a year, you haven't set up, you're studying the leachate, you can recirculate it inside the system. That means take it back, put it into the covered area, where you should have a piping system for being able to irrigate the covered area beneath the cover. So that's recirculation. So these are the strategies which one has to use for managing leachate. Expensive strategies. What do you do for gas? Well, if you don't cover the landfill, then the gas will slowly get produced and it will diffuse out and disperse with the wind. This would be fine, but greenhouse gases are coming out in a big way from these landfills. So methane is a big, big culprit. So nowadays we don't allow or don't expect that engineered landfills will allow the gas to go out. So you can have passive vents. So this is over the entire surface. If you put an impermeable cover, you can have small pipes coming out of it. If you don't have the initial money, after some time you can connect the passive vents to pipes and collect and flare it. You can burn the methane, and in the end you can use the methane for cooking gas or heating of homes or power generation. So this is utilization. It requires an investment. It requires deodorization. It requires deodorization, and this is an intermediate step. You can collect and flare it. When you flare it, methane turns to carbon dioxide, and that is much 1/20th greenhouse gas effect in comparison to methane. So these are the ways in which we can manage the emissions. Any questions or any thoughts, any suggestions? We could do it better. Okay. We have to do the geotechnical design of many components, and this is what we will cover in this course. Embankment design, liner design, leachate wells and drains. We will not be doing the hydraulic design. So we are not going to do open channel design, pipe flow design, pump design, estimation of floods, estimation of. What we'll do is the geotechnical, the wells which go, the cover design, the gas wells we'll do, stability analysis, environmental monitoring, what is buried inside the ground, and the bulk of the cost of a landfill is by all these operations: waste placement, embankments, liners. So we look at how to estimate the quantities and costs of landfills. In the end, we have to have a closure and post-closure plan, and the idea is that we should be able to, after you walk off the landfill, and if the waste is becoming stabilized, we should be able to return the, we should be able to restore this land to its original condition. So we have to ensure in the closure and post-closure plan that we monitor it for 30 years and ensure that all the components continue to remain functional. We want to achieve the ended use, the end use of the landfill, that means golf course or parking area. We have to continue to remove the surface water, and we have to continue to maintain it. So we'll look at this a little in detail in the next class, but the concept is that after you have finished filling the waste, you have to ensure that for 30 years you monitor it, and best is during the monitoring you have some kind of an end use plan for yourself. And finally, if it is going to become stabilized waste, then you have to ensure that it becomes part of the ecosystem. And does that mean I have to dig it out, or does that mean that I restore it to its original condition? We will see in the start of the next class. Any questions, any clarifications?
Sir, how can we control the fire coming out of open dump?
We will do this when we are talking of rehabilitation of old dumps. The question that is being asked is, how do we control fire which is coming out of old waste dumps? You know, many waste dumps have got smoldering fire and smoke is coming out. So we have we are going to separately address old waste dumps. At the moment we are doing design of new facilities. When we do old waste dumps, we will see how we tackle old fires which can be deep seated because of methane burning inside the waste dump. We will take it at that time. Okay. All the best. Have a good day.